In the last video, we designed a data definition that represents someone's title. In this video, we'll design a function that takes a title and checks to see if it's a professor's title. We're starting with the data definition from the last video. Remember that it's an optional, which means it has the normal case of a person's title being a string, but it also uses the special case none to represent an unspecified title. The problem statement tells us that we want to design a function that takes a title and returns true if it's a professor's title. The problem statement does not tell us how to determine whether a title is a professor's title. That's up to us to figure out. We'll use a simple rule that if the title contains the substring prof, it's a professor's title. As always, we'll start with the stub, including signature and purpose. We need to choose a meaningful name, and since our function will figure out whether a title is a prof's title or not, we'll call it isProf. We know our function takes one input of type title, and that it returns a Boolean. The next step is to design our examples. I'll start by writing a few. There, now we have 3 examples. You might notice in the first 2 examples, professor is capitalized. Our examples will force us to think about the cases for which we want our function to return true. Do we want our function to return true if it's given a title containing the word professor that is not capitalized? The problem statement doesn't tell us, so we have to decide what would be the logical thing to do. I think we should expect our function to return true if it was given the word professor uncapitalized. So I'll write another expect as an example, and once our function is complete, to test that case. Now would be a good time to check that our examples and our function design so far is consistent with our data definition. This function takes a title, and if I scroll back up, I'm reminded that a title is an optional, meaning that it includes the special value none, which in this case represents that the title is unspecified. I need to make sure to include an example for the special value none. So if somebody has an unspecified title as represented by none, are they a professor? Maybe, but given their title, we don't know that. An unspecified title does not represent a professor title. So we'll have our function return false. Now I need to run my examples to make sure that they're well formed and that they do not cause syntax errors. And I do see an error here, so let's read this and we can use the error to help us figure out what went wrong here. So on line 11, the isProf example, we gave it the input none. Oh, and it says it expects one parameter, but was called with 2 arguments or 2 inputs. So if I go back, I can see that the problem I made is in my parentheses. isProf takes one input, one argument, but I forgot to put the closing paren there. So it was actually passing it none and false. So that was a nice example, and we could see how to read the error message to help us fix an error. I'll run again, and this time hope that they really are well formed and do not cause syntax errors. There we go. So we can see that we do not have any errors like we did the time before, but most of our tests fail. And that's what we expect because we have not yet finished with this function design. The next step is the template. Our data-driven template is based on the type of the input data. So I know that I need to base this template on title. I'll copy the template from title into my function body. Now the last step is to finish the function body. If t is none, I want to return false. And I know that because we wrote an example. So we want to take advantage of the work we've done writing the examples. And I can see if the input is none, the output should be false. Otherwise, in the normal case where t is a string, I can look at my examples and see that I want to return true if it includes prof with a capital P or prof with a lowercase p. I wouldn't expect you to know this code off the top of your head. You would have to go and look up in Python, how do you check if one string is a substring of another. I happen to know the code because I just looked it up. So I know that I can check prof in t, so in is checking the substring, or prof with a capital in t. So what this is doing is it's checking, is the string prof, all lowercase, does that exist anywhere in the string t? Or does the string capital P, ROF, exist anywhere in the string t? So let's run this, and now we think our test should pass. And they do. So what we've just done is completed a function design for a function that takes an optional. We based our data-driven template on the template that we wrote in title.